Are you going to mute yours? Or is that mine?
Oh, yeah. I'll mute. There we go.
All right. Cool.
Okay. Welcome, everyone, to the January Toronto PerlMongers meeting. And we have here Doug Hoyte, who's going to talk about this new project? Adventure?
Sure. All of the above.
All right. Take it away, Doug.
All right. Thank you, Dave. Yeah, so I quit my job a couple months ago, or a month or so ago, and I've decided to work on this project called vmprobe. And let me just give you a little bit of background first. A few years ago, like I think 7 years ago or something, I wrote this program called vmtouch. And it's a pretty simple program. And I just released it and pretty much didn't have any, I never promoted it, there's no advertising or anything, just put it on my website and let people edit. And you know, basically these were the few examples I had of how it works. You can basically run it against the directory or file, and it'll say what proportion of that file is currently cached in memory and which is still on the disk. Because as you guys probably know, Unix systems have this in-kernel cache called the file system cache. And every time you read a file, it reads it from disk and stores it in memory in the file system cache. And then, you know, if you ever access that file again while it's still cached, it'll be really fast. It won't have to go to disk, right? So here's the first example is just, you know, seeing how much of the bin is currently in cache. And there's also a verbose-ish kind of mode that you can run, and it'll print out this little ASCII art kind of thing, right? So if you run tail on this bigger file, you'll see these O's here indicate that the end of the data set is in memory. And the spaces are here are the parts that are not in memory, right? And that was kind of the idea. And then, you know, here's just sort of there's two flags that allow you to actually modify what's in the file system cache. There's -t, which is touching it. I just called it that because, you know, it kind of reminded me of the Unix utility touch. And here it's I'm just running vmtouch-t, the big data set, and it's actually it maps that file, it memory maps the file, and then reads every page from that file to force it getting loaded into the file system cache. And then you can see, like with vmtouch, you can see an animated progress bar as it happens, right? And then, you know, the opposite of touching is evicting. So the -e flag will actually kick it out of memory. So if it's in memory and you run -e, it'll you know, force the operating system to discard it from the cache. So the next time it's accessed, it'll have to be loaded from memory, or loaded from disk, sorry. And then, yeah, the final thing is to take advantage of this operating system feature called memory locking, whereas if you map a file, you can lock it with the mlock system call, and that prevents the operating system from evicting it itself. So I just released this program without much promotion or anything, like I said, and lots of people have found it useful, which has been a big surprise to me because I've done a whole bunch of other things, and this is by far the most successful, I guess. So all kinds of people have written articles, including Sysadmin magazine. You know, this is just like I did some Google searches a while ago and put on the various entries and websites and stuff that people have mentioned it, and then, you know, of course, I got a ton of new traffic when Instagram revealed that that's one of the things they used actually to power their architecture. And then also, you know, tons of stuff mentions on Stack Overflow. It's packaged for a bunch of systems. Anyway, it was a really big success, relatively speaking, for my own stuff. So, like I was saying, I recently quit my job and decided to work on this new, sort of next generation of this of vmtouch. I'm calling it vmprobe. And I'm kind of at the point where I can now start to demo it a little bit and show what it's about. So yeah, and you can see it's at vmprobe.com there if you want to see more information about it. But yeah, so if I after it's installed, you can just run vmprobe, right? And that's can everyone see this? Okay, is that big enough font size? Yeah. I think it's okay. So yeah, so basically you can just run vmprobe, and it works kind of like Git, right? You have to provide a subcommand. So just vmprobe by itself isn't enough. It says, you know, it needs a subcommand, which is either which is any one of these things, right? And then the simplest one is probably vmprobe version. And all that really does is connect all of its remotes, and I'll talk about that in a second, and then tell what version of vmprobe is running on those remotes. So here, by default, the only remote is localhost, right? But you can change that and specify your own. And these are the same hosts as, like, for example, SSH, yeah, because that's what it does underneath. It SSHs into these remotes you specify and runs vmprobe on the remotes. So you can specify any host and SSH, you can run that too. So, you know, it's just taking a little longer because it's probably paging in SSH daemon, and it should hopefully work. There we go. Yeah, so, you know, I just SSH to localhost. And of course, you can specify multiple remotes. So, for example, I specified two remotes there. And there's also ping. There's ping is another subcommand, and that actually just does a connection, and then tells you what the latency is to those things. So vmprobe is two things. It's a command line interface to similar technology of vmtouch and other things, and it's also a graphical user interface. But first, I'm just going to show like a little quick summary about the command line. So most of the vmtouch sort of equivalents are grouped under the cache subcommand. So if I go vmprobe cache, and then at that point you provide a path like you would with vmtouch. So for example, I've got this relatively big manual file here, and I'll just specify that as a path. And then I'll run the sub command show. So what I'm actually running here is vmprobe cache show. And basically that works pretty similar to vmtouch, except the nice thing is that I actually, instead of just using little o and big O to signify, you know, some of those pages are in memory versus all those pages are in memory, I'm actually using a full range of Unicode characters. So if I try and, you know, open up this file, boom. Just put that in the background, and then I'll run this again. So you can see it paged in a little bit. Yeah, I guess it probably scans and loads like every 100th page or something, I guess, to create an index or something. But yeah, notice how it actually touched all of that file, right? It went over a whole bunch of those pages in the file all throughout the file itself.
So does that mean it read the whole file, but it didn't cache it?
I'm not really sure how PDF works, but it probably like skipped ahead to like every page to read or something like that. I'm not really sure why. But for example, if I'd done like tail on a big text file, it would just load the end, of course, right?
Yeah.
But for some reason, the events PDF reader processed a good part of that file. But notice how it only paged in 10 megs out of the 360 megs there, right? And you see this like bigger blip in the middle here. That's probably where I am here, right? Like somewhere in the kind of, what am I? I'm like 3/4 through this file here. And then yeah, it's probably that, right? So if I go and like page up a little bit, you know, it's probably like it's building like what do you call those thumbnails and whatnot. So now it should probably have paged a little bit more, right? Yeah, paged in a little more. That's why this rectangle is a little bit bigger, right? What's that? Possibly, yeah. That might be what it's actually reading and skipping the body. That's very possibly it. Yeah, yeah. So that's a good suggestion. Exactly. That's probably really good. That's probably That's probably true. That's probably what those 10 megs are for. Is yeah, the thumbnails. Yeah. And then yeah, so vmprobe cache has a whole bunch of other subcommands other than show. And yeah, by the way, you can always go --help and see more information about that subcommand. So you can see vmprobe cache requires a subcommand, and it needs either diff, evict, restore, show, snapshot, touch, so on, right? One of the neat things is the snapshotting and restore commands. So snapshot and restore. Those are features that are part of vmprobe that were not part of vmtouch. And they're quite useful, in my opinion. For example, that's what Instagram was basically using vmtouch for. They kind of hacked on really, really simple snapshotting functionality onto vmtouch, but it was at a file granularity, whereas vmprobe is actually at a page granularity. So one thing you can do is you can go vmprobe cache, specify the path, and then snapshot to, I'm just going to call it current.snapshot. And then that took a snapshot of the current file system cache state, right? So if we look at that again with show, that's what it recorded. It recorded basically that picture of what files are currently in memory. But it recorded the full detail, right? Like there's a little bit that you can't represent in there, just because it's the limitations of the ASCII Unicode display. But yeah, then another thing you can do is a vict. Well, I'll do touch, but I'll control C it a little bit of the way through. I don't want to load it all in. So yeah, so you can see I was able to touch that far before I control C'd it and stopped it.
Now can you do a diff between the...
You can, usually can, yes, normally can, but the diffing functionality is a little bit broken now, so I'm not going to embarrass myself like that. But next release will fix diffing. But yeah, so suppose I want to restore back to the way that snapshot was before, right? You can just go vmprobe cache restore, and what did I call it? Current.snapshot. And note how I didn't have to specify the path. That's because the path is actually embedded into the snapshot.
Mm-hmm.
But yeah, you can see that now we've restored it back to the original state that it was in. It brought back in all the pages that were originally there and kicked out all the pages that were in there before but weren't in the snapshot. Right?
So this is just looking at just that file. So if you're in another session snapshotting a different file, it would be totally different.
So if you're a different file, it could very well be different. But the session is actually not, sorry, like what do you mean by session? Like if I open another terminal or something? Or so the file system cache is actually shared by all of the users on a system, right? So it's actually global to the system. So every user of a Unix system shares the same file system cache.
So I guess like the size is just like...
Yeah, so that's one thing that, you mean how there's 16 megabits before, but there was 15 when we took the, yeah, I think that's because the Linux kernel actually does a little bit of read ahead that's a little bit difficult to control for. You can do some F advising and so on to try and limit it to keep it so that it's not reading ahead too much. But sometimes, yeah, Linux kernel just reads ahead a little bit. I've got some ideas about how to prevent that, but yeah, currently it's not completely perfectly accurate in all cases. But
does that like cause any corruption or anything?
No. It just loads. It may load a few more pages than were initially in there in the snapshot. But yeah, I'm doing a little bit of research to try and figure out how to prevent that. I have some ways, like for example, if you partially mmap a file and end it at exactly where you want to page it in, and then do an F-advise on that, you might be able to prevent the read ahead. But I still have to. At this point, I'm not really worrying about it too much, right?
You're trying to game the system at that point.
Yeah, I'm trying to, basically you're trying to outsmart the Linux kernel or whatever operating system kernel. Yeah, so those are the basic subcommands of cache. And there's these other commands. But yeah, the main other one is vmprobe web. So this is the one that I'm putting a lot of effort into. So if you run vmprobe web, it runs this web server, and you can see how it's saying now it's listening on port 5000 on the local machine. So now you can connect to it. Let me just open this. And right. But yeah, this is the interface. And there's these buttons on the left that you can click on, and they'll open new windows, right? This is a window, by the way. This vmprobe, oops, sorry. But yeah, if I open server list, so yeah, these are windows. It's like a windowing system, right? And you can resize windows and minimize them, and so on. So it's a pretty like intuitive interface in my opinion. But yeah, so this is just saying, this particular window is just saying what all servers I'm connected to, right? And you can see it says I'm connected to localhost, and the check mark means that it's properly connected, and this is the vmprobe version and the operating system that's running on. And a lot of things you can hover over and get like tooltips, and it'll say what more information there. And yeah, so the little globe symbol just means that it's a remote. It's the name of the remote that I'm currently connected to, and so a bunch of windows have those kind of things. So I'll just I'll just close Circle List here.
Comment from the web. Ooh, sexy booty.
Well, thank you. So then, yeah, another interesting one is the memory info here. So this is kind of like loosely inspired by like if you look up here, my GNOME system info thing there. So you can see how it's got like green, and it does it over time. It shows what proportion of your memory is used by programs, what part is used by the file system cache, and so on. I've sort of took that and went to another level. And at this point, it's just a current snapshot of what's going on right now. But eventually, I'm going to actually, I'll also have a time visualization, so you can plot this over time, and it'll have a similar kind of interface. But yeah, so this is kind of a similar thing. And you notice here that there's a row here for localhost, and there's one at the top, right? Because I only have one remote connected right now, these are the same, right? But if you were connected to a bunch of remotes, the top would be the total memory information, whereas each row here would be specific to that particular remote. So if you hover over it, here you see we've got 1.3 gigabytes of my 4 gigabytes of memory is in use by anonymous memory. That's like programs. That's like my browser, for example's heap, and whatever Google Hangouts is running for processes right now probably has that. And then I don't know if you can see this thin little bar here, but that's the swap cache. What that basically means is that sometimes memory is swapped out because the operating system needs to make room. And then if it pages it back in later, why would it bother deleting off the swap, right? It may as well just keep it there. And that way, if it ever needs to swap these pages out again, it just throws them out of memory, and it knows they're already in the swap file, so I don't need to do anything. Yep?
A question from the web there. How many remote sessions can you connect at once?
Well, I've tested like 10, 15, somewhere around there so far, but there's no actual limit right now to the number of remotes. I'm doing a little bit of scalability work right now. Right now it's using a pure Perl event dispatching library, but I'm just waiting on the one patch to be incorporated from net OpenSSH, and after that I'll move to EV, which is a really optimized C loop. But yeah, in theory, I don't see any reason why after I make a few more enhancements, it couldn't do hundreds or thousands of remotes. I mean, the interface might need a little more work, but the back end of it is perfectly fine.
Is it to libev?
So it's libev actually.
Libev is the one for home.
Right. Yeah. So it's kind of before Node went to the libuv, it used libev. Yeah. So that's the one that's packaged with Perl.
Yeah.
I don't know if there is libuv bindings. Is there?
Yeah.
Okay. Yeah. So yeah, I think like one of the main advantages of libuv is that it supports Windows properly, right? Yeah. So if I might look into libuv eventually, but for now EV is good enough for my purposes.
1986 code. They want their color scheme back.
Well, maybe I can make color themes or something later. We'll see.
Those are approximately the 3 colors that the original color monitors could render.
Well, then I chose well, I guess. If you ever want to run it on a 80s display. So yeah, so then the big blue one is the page cache. That's like your standard file system cache. That most when vmTouch reads, it's typically looking at stuff that's in the page cache. And this big blue one is system or kernel memory. And that's kind of like a big grab bag of a whole bunch of stuff that you can see in there, like buffers, page tables, the slab, kernel stacks, and so on. And then, yeah, this is just some unaccounted for memory. Meminfo is not 100% accurate. I think it might have to do with something like non-atomically updating the kernel the kernel lists, LRU lists and stuff. But yeah, it's usually a very small percentage of your memory. And then the big black is the empty, not used memory right now. But yeah, so that's kind of like the high-level display. But you can sort of expand and look at more information by clicking the system details. And that actually expands the purple into all those things I was talking about. So you can see here the buffers is taking up 62 megabytes, right? Buffers in Linux are kind of like a little bit of a grab bag, but by far the most common thing is like the ext234 metadata and stuff that's stored in it, right? So if I do, for example, like I go find you'll see the buffer start to grow as it pages in more and more of that of the ext metadata, right? And then page tables, those are actually the data structures that manage virtual memory. So they're quite important because those are the things that actually turn your virtual addresses, or like facilitate the converting of virtual addresses into physical addresses where your memory is actually stored, right? So if you have a really strange workload, that might take up more, but typically it's no more than 1% or something. And then these two are the slab. The dark yellow and the lighter yellow are the slab, kernel slab data structures. And basically what those are is a kind of dynamic memory caching system in the kernel. And there are all kinds of things, like for example, inodes are cached that way, directory entries are cached, and a whole bunch of things. There's a really cool utility called SlabTop. It can actually show you, for example, I've got 22 megs are storing directory entries and so on, right? And it's kind of like top, but it shows that in there. Eventually, I'm going to expose all that information into the GUI here as well, but it's not there yet. And yeah, the slab is split up between reclaimable and unreclaimable. Yeah. And the red is kernel stacks. Those are like the different threads that are running the kernel. How much memory is there? And then yeah, so that's the system details. But normally you don't worry about that too much. You just think that purple is like what my kernel's using right now for its stuff.
SlabTop on your utility?
Oh, sorry. No. SlabTop is a standard Linux utility. Yeah. Yeah. I can't remember what package it's in, but it's usually on most Linux systems has it. Yeah. And then the second check mark here is LRU lists. LRU stands for least recently used, and even if the kernel uses a little bit more advanced algorithm than that, actually it doesn't really, but suppose it did, they're still called LRU lists because that's just the traditional way of caching and traditional cache management policy, right? Basically, the stuff that's used most frequently or most recently, you figure is going to get used again in the future, and the stuff that hasn't been used in a while probably won't be used again. So if you click this, it splits up the memory into a whole bunch of into a variety of other little bars there. So you can see this dark red here. That's active anonymous memory, and then this lighter bar is inactive anonymous. So now you can see that this LRU list called the anonymous LRU list, which includes a whole bunch of other things as well, other than just the anonymous pages, is split up into those sections, right? So you can see about 1 gigabyte of it is active, and 400 megs is inactive. And similarly, the page cache is split up at there's a LRU list called the file LRU list, which deals with pages that are, pages that have file backing them. They're mapped from a file, whereas the dark red ones don't have a file backing them. But yeah, these purple ones, you have active and inactive file. And then you have a bunch of memory that's not on the LRU lists as well. But yeah, the LRU lists are kind of neat because they can give insight into what sort of memory workload you have. Like one interesting demonstration of that is if I access that big PDF file I have there, you'll notice that it's expanding the inactive file one, right? So it read it from disk, and it stored that in the inactive file. However, if I access it again, it puts it into the active. That was maybe a little bit too quick to see, but I'll show another demonstration of that a little bit later. Yeah, so that's, and then of course if I evict it, yeah, Rich.
Well, just a question about so how does it go from active to inactive again? Some time-based or?
So it's a bunch of things, but it's usually it's based on the LRU policy. So yeah, it's sort of access. It's based on the access of it, right? If it's accessed frequently, then it'll stay in the active. Otherwise, it the kernel speculatively puts it back into the inactive. And if it stays in inactive for too while, it gets evicted.
Okay, so it's just a way of our kernel to label it, so that there's a block of memory that's inactive, I can do something with it, just evict it or.
Yeah, basically, yeah.
Or something.
Yeah,
Well,
basically.
maybe the policy can actually just drop it.
Yeah, and then if you evict it, it gets thrown back out of the active again. So yeah, that's pretty much the memory window. I have a bunch of other ideas about how I'm going to make that even better, but that's basically what it does for now. So the next thing, next part of it is the file system cache window. And this is pretty similar to the display that we were looking on the console, right? So if I add that path, that PDF file path, now it's added, right? And you can see this is the remote, and the path is getting clipped there, but you see the PDF. I should add a tooltip there, actually. That's a good idea. And then the next is the residency. This is kind of analogous to the display that we were seeing with the rectangles on the command line. And you see that it's all gray, right? Which means that none of it is in memory. And you see that tooltip where it says 0 of 60 megabytes, right? That thing that I'm looking at there is based on this little rectangle that I'm highlighting, right? Or hovering over. And then I can also select portions of it, and I can say, based on my selection, it says down here, I've selected 64 megabytes, and none of it is in memory, right? So these little buttons next to it are kind of related to the similar commands that vmtouch provides. You have touch, which brings it into memory. You have evict, which kicks it out of memory, and then you have lock, which locks it into memory. So you can see if I touch it, it'll actually bring it into memory. And you can see actually it did a little bit of read ahead here, right? So it read a tiny little bit ahead, half a megabyte into that one. That's why I don't know if you can see it on the monitor there, but this one that I'm hovering over right now is slightly darker gray. I might want to work on these color schemes and change, because right now it's just a linear blue channel. I have some ideas about how to improve the dynamic range of that a little bit so it's easier to see. But yeah, so that's still selected. Now you can see 64 megabytes of my 64 megabytes that I've selected is in memory, right? And then of course I can page that out again, and it's gone, except for that little bit that was in read ahead before. But anyway. And then this allows me to unselect or select all the pages. And then, yeah, I can bring just some other little bits of it into memory if I want. That's sick. Well, thank you. And, yeah, so, yeah, I don't know if you can see at the top there, but every time I do an action, there's these little green arrows in the title bar. So if I go bring all of in, this green arrow that was there, that represents a task that's running on the remote. Right? So you can have multiple tasks running on the remote, and they can be queued, and so on. But yeah, that's just one interesting aspect. Sure.
Let's say you had 10 remotes here, and they all have, let's say, the same file. Is there an easy way of selecting all 10 and doing the same operation on all 10?
No, but that's on the to-do list. Yeah, I do want to have that. Yeah. So yeah, it's kind of like a nicer interface to what the vmtouch and vmprobe give you on the command line, right? And then, yeah, so I can select all, select none. And then this next one is to take actually a snapshot. Remember we were doing snapshots on the command line? This is a way to do it on there, in the GUI, I mean. So for example, if I go, actually just one thing before I do that, I just want to show you one thing. Suppose I want to lock all this stuff into memory. I'm going to click the lock icon. Oops. See this flame that came up there? Fail. I can't. I exceeded the allowed amount of memory, right? So I tried to lock 400 some megabytes into, or 360 megabytes into memory. My user is not given the permission to do that, right? So for example, if you look at new limit, you see max locked memory. I'm only allowed to lock 64K of memory, right? So obviously that's not good enough. That's not going to work. But I'll show you a little bit more details of the locking in a minute. So yeah, so the next thing I just want to show is the cache snapshots window. So the cache snapshots are kind of sorry, it looks a little bit odd on this smaller display. But yeah, basically in that directory in the title bar, it stores snapshots of the it stores the snapshots that you've taken. right? So here's, for example, me screwing around with some other snapshots, right? So 6 days ago, I took this snapshot of the same PDF file, and also on localhost, and here was the cache state of what it was like, right? Well, what you can do is you click this, you drag it over here to the remote that you want to install it on, localhost, and then bang, it restores this same snapshot as it was 6 days ago, right? And you can see it's back in the state it was now. And one thing is that notice how it's showing me 32 buckets. It's showing me 32 little rectangles basically here of that. If that's not granular or enough, or is too granular for you, there's these zoom in and out buttons where you can actually improve the granularity, right? So or change it, right? So now I'm down to like 2, right? So this is like 100 megabytes here, 256 megabytes there, right? And then if you zoom in a lot farther, you also get much more granular collection, Is that me?
I don't think so. Someone,
I think we're good now. No? Can you mute everyone, Dave, or is that? Can you mute everyone, Dave, or is that rash?
So we are broadcasting, but the moment we try and go
Okay. I think. Okay. Is that good now?
Ah.
Oh, okay, cool. Okay, cool.
Sorry, Foco.
Okay, so
There was a comment, by the way. Holy Mother of God, transient state recovery.
Nice, thanks. That's a good one. I should have to put that in one of the bylines. Yeah. But as you can see, like now it's much more granular, right? So if I zoom in one more, I think I can do. I've done like 6 megabytes now. As before, I was doing like whatever it was, 28. And each thing I hover over is 64. Oh yeah, and by the way, I've been showing just files right now, but you can also do whole directories, right? So VM Touch, like this is, for example, a big directory, right? It's just my VM Touch repo on my file system. So you can see as I'm hovering up here, this is like the Git stuff, right? And then back over here, I've got the big pack file and the Git, the .git file. Over here is like my actual files, right? So like for example, I can go VM Touch, and I can go like Git status, and then you see that actually paged in some Git stuff, right? Paged in part of the pack file. It paged in individual Git objects, like the ones that are in the head, and so on. I can go Git log, whatever, and that'll actually read in all of the objects that are in my Git log, right? And then of course, if I want to read in, there, I guess that just reads like the commit messages and so on. If I want to actually read in all the pages and stuff, I can go -log-p, and of course that actually shows me all of the diffs as well. So it'll have to load in all of the objects. So now it loaded in everything, except for probably a few of the orphaned objects there, right? Yeah. And then here I can actually show you the locking too. So I can, here I've selected only 8 kilobytes, right? So that's well below my 64 kilobytes of memory limit. So here now I can go lock. Click the button, and bang, you see this lock has appeared there at the bottom. So it said, 8 kilobytes of the binary has been locked a few seconds ago, and that'll stay there. Like for example, if I try and evict everything, well, guess what? That little bit that's locked is still there, even if I evicted a bunch of times, right? It doesn't go away until, of course, I unlock it. Now I can evict it. So that's the concept of locking and unlocking files. I'll show you a little bit more when I do another demo in a second. But yeah, that's the fundamentals of the product right now. And yeah, I think I've showed most of it. There's a few other little things, but I'll show you another demo now with more stuff. So yeah, let me just close this and go over here. Oh yeah, error messages also appear in the console, right? That failed to mlock. So I'm going to Control-C that. And now what I want to show you is a little bit of how I like to develop this thing. So if I go into vmprobe, here's the repo that I just cloned from GitHub, and there's this top-level script called build.pl, and there's a file that says all of how to build from source, all the steps you need to do it. But yeah, basically you can just go build pl quick dev, and it'll install your cpan dependencies. It'll install your npm dependencies. Npm is, for anyone who doesn't know, it's like a JavaScript cpan basically, and I use quite a few modules in there to build the GUI, and I'll show you about that in a second, a little bit more in a second. But yeah, so once you've done quick dev, you can actually run Perl. Inside here, there's the actual like a Perl distribution of that, because there's other things like the lib vmprobe directory, which is actually a C++ library that does most of the underlying stuff like memory locking and touching and evicting and all that stuff. But yeah, in the capital V vmprobe directory is the actual Perl module. So let me just quickly show you something here. So if I go run this one here, it's gonna run it. But notice how it's actually running Webpack with devconfig, because I ran it in the repo. It's right now it's compiling a React hot loader to do the web interface. So if I open my browser now and go to that URL again, you can see it looks basically the same. But yeah, so you notice how Webpack is now set as built. Has anyone ever used Webpack or React hot loader and all this stuff before? Or? Yeah, it's fun, eh? So yeah, I just want to show you like some the basic stuff about it, right? So everything looks the same, but one of the really awesome things is that when you modify a JavaScript file or any of the other assets that it manages, it will detect that that file has been modified, and then Webpack will recompile it and send basically a new version over to the browser. And then the browser will work out what the differences are and apply them without disturbing any of the React state or the state of your elements and so on, right? So for example, if I go into the web directory, which is where all this stuff lives, and I go source, Windows, what am I looking at? Server list. And then suppose I want to change this text remote, right? Where is that? So I've got here. Say if I want to just go the remote or something, right? I haven't saved the file yet, so nothing's changed. But as soon as I save the file and go over here, it changes in there. There's no reloading or anything like that of the browser. So yeah, it's extremely handy, right? And pretty much everything can be done that way, right? So for example, if I go, console.log, it is rendering. Right now, if I go open the this here, I see how I'm moving stuff around, whatever. As soon as I save this, now it is rendering. It appears, right? Because it actually installed that new render function and reran it just in case something might have changed. And then it gets the output of that and diffs it against what it was before to do any changes. But you can see how it actually ran the new code in there without ever having to Control R reload the page, which I don't know, which is actually it's a huge deal if you've done web development before. It's like I would never want to go back actually to the old way. It's like having to make a change, Alt tab over, reload the page, set up your navigate to where you were in the page, set everything up back in the way, and say, oh yeah, that color I wanted to change changed. It's like this just it's just instant feedback. It's a great thing. And yeah, another neat thing is you've got this see these things that are changing over there, the purple stuff. That's it shows you the DOM. There's also a React tab here where you can go, and then it actually shows you you can actually look at the React elements, right? So I'm actually seeing resource window. Serverless is a resource window, for example. That's what this is, in fact. And you can actually see not just the HTML, but the dark purple are actually my React components. So yeah, it's a really, really fun way to debug and develop. Okay, yeah, so that's basically, I mean, if we have time, I can show some more of the code or demo more of React or anything else you like, but I just want to show another real quick demo here. So before I came over here, I set up a bunch of AWS stuff. So there's this. So yeah, AWS stands for Amazon Web Services, and basically it's you sign up for an account and then you can pay a little bit of money. It's not very much, but you can start a whole bunch of machines virtually in the cloud and do stuff with them. And you know, before I came over, I set up 4 of these EC2, which stands for Elastic Compute something or other. So Compute Cloud. Okay, cool. So yeah, and I set those up just for the demo. But I actually just want to show you one other thing that's really awesome. Has anyone used CSSH before? So it's this. It's basically this program that lets you connect to all of the machines at once. So you can go cat hosts. So basically, I'm going to run CSSH and all of those hosts, and it's going to connect all of them and put them in Windows here. And then this little window down here is, you know, where I'm going to enter my stuff. And I can say, you know, who am I? And then it basically does it on every single one of them, right?
That's pretty easy.
So it's really awesome. Like, all you have to do is set up a bunch of machines and then run CSSH on them, and then you just do your configuring once, and it configures all of them, right? And you know, it all works like info, whatever. Yeah, it's you know, sudo vi ets group, you know, EC2, like, you know, I can add EC2 user and see how it's editing all of those, and I can save, exit, you know, and I can, it's just a really neat program. But yeah, and then of course if you want to just do one thing, you can click on that window and just do it there. But yeah, anyway, CSSH is really cool. So yeah, a little bit of detour. Anyway, so now I want to show you vmprobe with this interface. So I think I just had some things. Yeah, by the way, yeah, so the way I got that host file is with this command, right? They have this utility called AWS, and it works kind of like vmprobe. It has sub commands, and you've got the AWS EC2 describe instances subcommand, and then I pipe that into JQ, which is like a jQuery processor, and it has its own little language. So like, for example, I just want to show you, like, if you look at the JSON that it returns, it's like this big honking thing of all your machines, right? So then if you run pipe that through JQ, and then I just extract reservation instances, get the public DNS name, map EC2-user, which is the default user. Oops, what's going on there? Oh, right. Thanks. But yeah, and that gives me the host, right? So I've basically got almost all this stuff automated now. Anywho, so yeah. So now going back to the vmprobe, I'm going to do this here because just there's a few more features that I haven't pushed to the official release yet. But yeah, basically I'm running Perl vmprobe like before, and then I'm doing using the -- sudo switch, which says when it SSHs into those AWS remotes, run vmprobe with sudo, and that will let me do things like block more memory and stuff like that, right? And then I'm saying use the vmprobe binary user local bin vmprobe, just because when you run stuff as user local bin isn't root on the Amazon machine instance Linux thing. You shouldn't normally need to do that, but here I'm using it. And I'm saying remotes file, that host file that I showed you earlier with just those 4 hosts. And then run web. So, oops. Yeah, and then run web. Oops, okay. Right, so let me kill that sucker. Yeah, now you can see it added those 4 remotes. Now if I go over here, reload, I have to wait for that web package to compile itself, but it should be in a second. Come on, NPM, you can do it. Or actually, I guess it's just Node. All right, cool. So here we are again. Now if I go to server list, you can see that it's connected to all of those. And they're all running the vmprobe version. Oh, by the way, another really cool thing about React, or at least this one thing that I'm using in it, is see, if I minimize the window a little bit, you can see how it's now got a little scroll bar here, right, to show the remotes. One really cool thing about this fixed table React component I'm using is that it's right now it's actually not rendering those components that are off screen. So if I did have 1,000 different remotes that I was connected to, it would only render the portion of them that are in the viewport, right? Like the ones that aren't actually in the ones that aren't actually visible won't have any entries in the DOM, right? So it's quite, React is quite a good library. They've thought through a lot of this stuff about that kind of efficiency. But yeah, anyway, oh yeah, by the way, these X's are to disconnect the server. Yeah, and it's important to know the operating system and the vmprobe version, just so that I can
disconnect the vmprobe stuff? Or
yes.
Or
No, it just disconnects the vmprobe. Yeah, so yeah, so the server is not touched at all. It just closes the SSH connection to that server. Yeah. Yeah. So the hope is I'm hopefully going to maintain backwards compatibility across pretty much all vmprobe versions. So you know, if you try and do an operation that isn't supported by one of the vmprobe instances, since it knows the operating system and vmprobe version running there, it should say, sorry, can't do that here, and give you a warning, hopefully a way to upgrade the server too. So yeah, now here's where it gets a little more interesting. So memory info. Now, as you can see, each different remote has its own entry in this table, right? So you can see here on this first one, there's 268 megabytes in the page cache. Oh, by the way, each one, I'm running T2 micro or something like that, Amazon instances, which have 1 gigabyte of memory. And you can see the majority of it's in the page cache right now. You know, some of it's in the system, some of it's used by the kernel, but only a very small amount of it. Yeah, so that's basically it. So the other thing I did on all these hosts with CSSH is I mounted S3FS. So S3 is basically a way to store files in Amazon Cloud, right? And it lets you store big files, small files, whatever, but it gives a REST interface to access them. So people have made this fuse interface to it. So if I SSH into one of these, you can see I've mounted it. Oh, actually, sorry. I've put it into big files. Not really big files, but yeah. So anyway, I've mounted that. These are mounted from S3. You can see S3FS here. The interesting thing about S3FS is that every time you access the file, by default, it will go to S3 and download that whole big thing. But there's a flag you can provide to S3FS, which you really should, to cache it in a directory. So actually, so these files here, I've got like, you know, what are they, db1.log, db2.log, db3.log. Those things are actually cached in this directory I've called cached. And oops, it caches them there, right? So yeah, you know, here they're cached. So even the S3FS actually uses the file system cache, which is smart because the file system cache is a really powerful abstraction for caching files. Yeah, so now I'm on one of these hosts. I don't even know which one. The first one, I guess. Let me just like, I don't know, access one of these things. db1.log. So I'm going to MD5 summit, and then you can see, you should be able to see, yeah, Eric's loading it into the page cache to MD5 summit, right? And then, yeah, it should be done. But yeah, now you can see that 580 of the megabytes are used on the first server, right? And the page cache here. Yeah, one of the interesting things, one of the reasons why I did the sudo there is so now if I go to the file system cache and I go, right, so if I go home, EC2 user/cache, yeah, now you can see all of these servers have an entry for that file system cache. Right, so you can see on this first one I loaded, you know, all of this stuff, db1.log is in memory, all these 64-bit or 64 megabyte blocks. And then if I go over here, this is db2.log, none of it's in memory. db3.log, none of it's in memory, right? And then of course I can say, you know, all this stuff, load this into memory, and then if I go over here, more of it has been loaded, right? Yeah, by the way, there's a limitation right now in that, like, it doesn't issue multiple, it's not issuing multiple requests to a remote in parallel. So while it's doing the touching, it's not updating this screen. That will be fixed in the next release. So everything was going to be in parallel. So you'll be able to see this memory bar going while this thing is touching, while it's loading in memory. But yeah, so another kind of neat thing I wanted to show is, like, suppose on this host, if I go here, I'm going to select, I don't know, maybe, yeah, 768 MB, why not? I'm going to hit lock, right? As you can see, it's doing that here. It's running cache lock, and it's locking that path on that server. And it's going to take a little bit just because the EBS is quite slow on Amazon. So yeah, basically you can see now this guy has loaded a lot of stuff into the page cache, and it's locked there in memory. One interesting thing is that if we go to expand the LRU lists, memory that's locked is actually not on an LRU list at all. It's put onto an unevictable cache, an unevictable list. So that you can see here in blue, right? So now if I go back over to here, and I go evict, oh, that's not going to work, of course, because it's locked. If I close this lock and evict it, now you can see it's gone, right? And then, yeah, of course, we can do it the way before, right? If you go touch it, it puts it onto the inactive list here, right? Inactive file, right? If I touch it again, it puts it onto active, right? But yeah, so that's pretty much most of the demos I have for right now. I've got a lot more stuff planned. There's a few more really neat things I want to do about memory. Like, for example, in this display, the file system cache display, I know of a way to actually show the LRU list on that. So you'll be able to see which portions of the file are on which LRU list and stuff like that. And I've got, some other really cool ideas. Like, for example, ways to highlight bits of memory and give information like kernel same page merging and stuff to that memory. And basically, I've got a whole bunch of other ideas about really low-level memory stuff to do. And then after I've kind of got memory fleshed out to where I want it, another thing I want to do is start getting into other aspects. Like, for example, I really want a CPU profiler, right? So I want it to see, all of your CPUs on your cluster in one integrated display, and you can, hover over them and see what each one is doing at any one time, what percentage it's spending in the system in kernel code versus user's code versus idle. Also, I wanted ways to like throttle processes, so you can say like, this one job, I only want to be using 3% of the CPU usage across my whole cluster, and stuff like that, right? Basically, my goal is I really want like this high-level utility to manage your cluster as like a holistic sort of entity, right? So you can, basically like instead of running top on an individual machine, you're going to have something that's even better than top that works across your whole cluster, right? I really want like discoverability, right? So you load up this top equivalent, it would show you your top processes across your whole cluster. You click onto one, it would show you, what that process is doing, like what functions it's running at any time. You'd see its memory maps. You can click onto the memory map, see what of those memory maps are actually in memory. You can affect it. You can pause the process. You can throttle it. You can re-nice it. I've got a ton of ideas about really cool stuff to do. So yeah, so that's pretty much my presentation. Obviously, I'll answer any questions, or we can try other experiments if anyone's got suggestions.
Have you used HTOP?
HTOP, it sounds familiar.
I use that one a lot. I can see the different processors.
Okay,
Not
cool.
as much detail as you'd be wanting to go into, but it's nice seeing different processors, how much,
Nice.
Just app guide everything.
Nice, check it out. HTOP,
Yeah,
okay.
it's still an external application where Azure is web-based.
Right. So personally, I think web is kind of the future in a lot of ways. I really like the web, obviously. I mean, because for a variety of reasons, we can, it's got a ton of really reusable components and stuff to use, and also you can access from another machine, right? So you could have like a centralized vmprobe that everyone in the company could use. That's another kind of goal of mine. Richard?
For this now, are you using like a well-defined REST interface so that you can hook up scripts and other automation to the vmprobe web server?
Depending on what you mean by well-defined, yes.
Well,
There is an API.
Yeah, and there's plans for that one. They load that and then hook into that. Instead of just using your web GUI, they could write their own script to automating tasks.
Possible, yeah. Yeah, I haven't really considered that API as being something to publish, but very possibly, yeah.
That's probably everything's microservice.
Yeah, possibly. But yeah, I think vmprobe is going to be awesome for microservices, just because, like, you know, if you're in the habit of splitting up your application into a whole bunch of little pieces and distributing them across a whole bunch of machines, I think it's really great to be able to manage all those machines like one system, right? Exactly.
can save a lot on like file copy performance.
Yeah, exactly. Yeah, this HTOP looks pretty cool though. It's sort of it's definitely kind of similar to what I'm thinking too.
Yeah, the one thing I really like is like hit F5. I use a lot. So you can see which process, like the tree and process.
Oh yeah, that's cool. Yeah, I definitely want to have a process tree lister. Yeah, like obviously kind of similar to PS tree, right?
Okay.
And then I really love discoverability. So I really want to be able to click on one process and it'll show you what CPUs it's running on. Its memory maps, its open files, what locks it has in the file system, this kind of thing. Heat maps.
In terms of scalability, so let's say you have 1,000 nodes open on the screen. So all these events are happening on all these different nodes, like the programs are running, they're swapping things in and out of cache. Is that being event driven, or is it that there's a polling mechanism? And like, how are you gonna, if it is polling, how would you scale with it to get one more vote?
So it is polling right now. One of my plans for the future is to have a sort of vmprobe daemon that can run, like an agent. It would probably be started by your main thing here, or maybe not, but it would collect stuff periodically, right? The problem with a lot of these interfaces is that there isn't really an event-driven interface to them, right? Like there's certainly no portable event interface to say when a file is paged in or out, right? I do know of some ways to kind of debatably hack that into Linux, for example. There's the ftrace functionality, where you could actually hook into the kernel functions that say when pages are paged in and out. So in theory, I could get an event-driven input to that, but of course that's like a deluge of information, right? Like every time pages are paged in or out, which is basically all the time, I would have to do something in my code, right? So
polling would actually be more efficient.
For some things, I think polling is definitely more efficient. Right? Like there's, this. I mean, like most profiles are sampler profiles, profilers too, right? So it's not, polling is critical for some tasks, but yeah, I do really think that there's a lot of event-driven stuff, a lot of event-driven potential too.
So I was just gonna ask, would it be very hard to port this to like a mobile device? So if you have like your Android device, especially if you have your little RAM, one run faster.
Yeah, well, possibly. I mean, depending on exactly what you want to do. vmprobe itself doesn't take very much resources, but I mean, like the thing is that like if you wanted to SSH into it remotely and manage it that way, you would need to run an SSH daemon, and you need internet connection and so on, and there'd be high latency to it. The flip side is running this web interface on there on the Android itself means you'd have to have your own browser and manage it that way. I do really think that this interface itself could work very well as a tablet interface. So like for example, if you're on the train or something and there's some problem with your web servers, you can load up this vmprobe instance, and if I fix a few things in the interface, like making it touch friendly and so on, I think absolutely it could be Androids and whatnot could be a great interface to it, right? vmtouch is very lightweight, and in fact it is standard on some phones. Like the Memo phone is a Linux phone, and it ships with vmtouch. I only found that out because someone reverse engineered it and posted a process list of stuff, and sure enough, vmtouch is running on it.
Is it processor specific at all, or is it architecture independent?
So it's Almost completely architecture independent. Yeah. The main thing is that the only thing that would stop it from being that way is different page sizes. Right now, I know I've like kind of hard-coded an assumption of 4K pages in a few places, but really it's I would just need to like actually find a machine that doesn't have 4K pages and port it to it. It's not very difficult. It's just like not very much has 4K pages anymore, right? Sorry, things other than 4K pages. Yeah.
The one thing, it's clearly very powerful. I wonder if the potential for mischief is in there.
Yeah, well, there's definitely some mischievous things you can do with the file system cache. I mean, for example, one of the things is like evicting commonly used files, right? You can obviously reduce the performance of applications by doing that, right? Like consider evicting parts of libc that are accessed all the time, right? You would slow systems down to a crawl, right?
You split a hackathon cover.
The other interesting thing is leaking information via side channels, right? Like as I said, the file system cache is shared by all users on a machine, right? Mm-hmm. So sometimes like access patterns of files and so on can be inferred by looking at the shared file system cache, right? So you can see what some other process that you don't have permission to look into is actually doing at any time. Yeah.
Say you're running a distributed type of system and you're like deciding how many forks to do per computer with vmprobe used for that. So one for like the memory.
I think so, yeah.
You said you throw stuff. So.
Yeah, in the future, definitely, yeah. Yeah, I absolutely think it could be very useful for capacity planning. Yeah, I mean, just being able to load up even just this display and see what your memory is actually being used for right now might be useful just to say, oh, damn, I'm getting really close to my capacity on this one machine, right? Maybe I should upgrade its memory or whatnot.
And right now it doesn't have a daemon for computer. You say SSH.
Yeah, so exactly. Yeah. So SSH is in and runs a vmprobe that's installed there, and then they communicate over the SSH channel.
And the vmprobe stuff has to be installed with the machine, or you can send the code.
So right now you need to install it.
Okay.
Eventually, I want to have a vmprobe like deploy or install command or something that would actually SSH in there, figure out the operating system type, apt-get install it, or yum install it, or whatever as needed. Of course, that would be prompting you and whatnot.
vmprobe probe.
Yeah. So that's kind of the notion of the probe, right? Is like you have remote machines and you need to like connect to them somehow, right? So you take these little probey things, you send them over the internet, plug them into some other machine, and then you can communicate from your own, right? It sounds cheesy, but that's sort of the notion behind the vmprobe name.
With regards to your UI, when you start scaling to clusters of 10, 20, 100, 1,000, are you going to have the ability to create groups of remotes, add and remove groups or individual hosts from the main?
Yes, a lot of that's planned. Yeah, yeah. What I want to have is one of the things I want to do really soon off is a way to like save your state, right? So like right now it sort of works. Like for example, if I close this browser window and open a new one. And then go back. Stuff is still mostly there. It forgot some things like the window position and the fact that this was minimized. So, but it's almost there, right? So really, when because I'm using the browser strictly as a view layer, and the controller and the model are all separate, it's not really that difficult to save, right? Because all the state has been serialized and sent over to the Perl backend, right? So really, it's just a matter of saving that. Right, so I'd really like to have number one, a way to save this, and also the other thing is to take a saved one and install your own collection of remotes. And yeah, absolutely, I would love to have this server list here that you could maybe this would be broken down into subgroups, I guess, and you could unselect one and it would take away those from this display, or maybe maybe ways to control it in each display.
Maybe group machines together. These guys are web servers. These guys are.
These are my compute nodes. These are my storage nodes.
Yeah, definitely. I need to think about the UI a little bit for that, but that's definitely in the definitely in the pipeline.
This is just looking at stuff. I guess the next thing, a DevOps person would say, "Great, can I set alarms when I'm getting low on memory?" Or is that something you do through the API separately?
So I think I want to have something like that. Right now, it's not really a monitoring system exactly. It's sort of not really set up for that because, like, for example, if your SSH connection dies to this machine, it would stop monitoring, right? Which is obviously not ideal for a monitoring solution, right? Like if your desktop is no longer able to talk to the server, it wouldn't get any more information, right? I mean, that's kind of a fundamental problem with monitoring systems as a whole too. But yeah, if I do want to make like a reliable monitoring system, I'm going to need some kind of like persistent agent daemon running on machines.
Yeah.
Some kind of like failover nodes for reporting and stuff.
Would the plan be to run the vmprobe web just on one host and then have multiple? I guess you also have to have a multi-user story for this, but have multiple hosts connected to one vmprobe server. So all the samples are being sent to one server.
Yeah, exactly.
It's persistent and long running. It's not on your desktop. It's your data center alongside others.
Yeah, exactly. Yeah, that's sort of like one of my initial kind of ideas for the pro version, I guess, is like for a company that wanted to install this in a central location. And then, yeah, as you say, there'd be users with different privileges. Like some users would just be able to view, whereas the operations staff would actually be able to like evict files and do all this stuff. And there'd be logging and monitoring and so on. But yeah, it's I really do want to make like just for something you run on your own machine and you use for your own stuff. I want to always make sure that's free. As like a techie and sysadmin myself, I would not want to use proprietary tools just for that kind of stuff, right? But I think there's definitely a opportunity. There's definitely room for these kind of open source supported solutions.
I'm just seeing seeing this interface is like it's almost like a starting ground for a bigger system potentially. So like how like Slack, where you can kind of be creating like open it up to other modules so they can come in and put monitoring. So
yeah. Yeah. Absolutely. Yeah, true. Yeah, I definitely want like plugins and stuff and ways for people that add their own window without doing a huge amount of coding, right? I've done a lot of kind of thinking about the design of this. The way I sort of think about it is that the browser is like your view layer, right? And the Perl process that's running on your own system is kind of like the controller. And then all of the other remote like vmprobe processes are the models, right? So it's all kind of a little bit cleanly separated like that, right? So I think to add like another window, basically there's a very small amount you need to specify for each one of those parts, right? And I'm going to really soon have documentation for adding your own plugins and enhancements and whatnot. Martin?
You said these also have their own agents.
So all I did to set up those 4 remote hosts was use CSSH and then just run that cpanm vmprobe sudo command, the standard way to install it. So there is no agent right now. It's just you install it. It's kind of like the rsync model, right? Like rsync is installed everywhere basically. So you can usually just rsync something over, and then rsync SSH is in over there, runs rsync, and they talk to each other with the rsync protocol, right? So it's kind of the same way as rsync works. Yeah, there's no agent exactly, but it requires the software to be installed so that it can communicate with your software over the SSH link. Yeah. Do that from what, sorry? Oh, true, yeah.
When it hasn't been installed.
Yeah, no, exactly, yeah. I do want to do that. Yeah. Yeah, like I was saying earlier, I want to like kind of a vmprobe deploy or something. And yeah, you're right. I would probably bubble that up to the UI as well. So you could just like, the server hasn't been, okay, well, number one, you're having to set up your SSH keys? Click this button and we'll create an SSH key and enter your password and we'll go in there and set up the authorized hosts and then, now that we're in there, do you want to install a vmprobe? Just enter your sudo password and just install automatically like a worm.
So actually, this question: so you're using sudo on the root on the remote process. Does that mean that user that you're SSHing has to be set up with a sudo or non-password? Basically, to be able to just their wheel or something.
Currently, yes, and that's the way that AMI, Amazon Machine Instances, have it. They have it so that the EC2 user account doesn't need to enter a password for sudo. Technically, you could just set it up so that sudo, you can just run sudo vmprobe without a password if you wanted, but that's don't think you're getting any security because vmprobe can effectively do anything, right? Yeah, so that's that.
As far as colors are concerned, I think you probably have the least trouble from it if you set up a table. You just specify the various categories that the colors can come in, and it's up to the user to set their numbers.
Yeah, I'd like to have like a theme kind of a way to configure your own themes and choose your color schemes and whatnot. Yeah, I mean, obviously, as you can tell, I haven't put that much thought into it, but it's
Yeah, theme shop.
Kind of reminds me of like Fastest Windows 5.
Yeah, wow. You notice how my maximize buttons are on the right as God intended? Just joking.
Very crucial question. How much Python is involved in this?
Python? No,
Very crucial.
there's no
That's
Python.
the right answer.
Yeah, no.
Which Perl do you, what's the minimum level of Perl?
I believe I'm using 5.10. Yeah, I think I was using some 5.16 features, but I dialed that back a little bit. So yeah, I think 5.10 is the minimum Perl required. When I do package it in such a way that you can apt-get install it and yum install it and all these things, I'm actually going to bundle a Perl interpreter with it, just so that I control everything in the package, right? It's not that big a deal. It adds like one more megabyte or something to the package, so I'm not that concerned about it. And it'll just make everything a lot more contained. So at that point, I'll probably ship a 520 or something.
So you had this obviously one on Linux. Have you tried it on Windows machines?
Oh no. So
Solaris?
no. So the thing is that the web interface itself should run essentially everywhere. Everywhere that supports SSH, OpenSSH specifically. Whereas the actual backends, like the remotes themselves, they use some Linux-specific features. Like for example, this memory info screen right now is fairly Linux-specific, or actually it's completely Linux-specific. However, the other screens, like the file system cache, is actually not that specific. In fact, I think with a little more tweaking, I could easily get it to work on BSD and Mac OS. But yeah, it's kind of a little bit Linux specific everywhere. I need to do some serious development before I'd actually say it's supported on other systems. We'll see if my customers actually want that. I honestly don't really think they will, because, you know, like it or not, basically the whole cloud runs on Linux now. So
Windows is a completely different animal.
yeah, so Windows is, I mean, I'm not even approaching it right now. What's that?
Do you already have users?
I've got some people that are checking it out and like beta testing it. I don't have any paying customers yet, but you know,
Getting mind share.
working on the mind share, exactly. So with VM Touch, a ton of people use it, right? Like Instagram, Spotify, they all use it in production stuff. So yeah, it's, you know, I'm hoping that vmprobe will add an extra level of additional value that companies like that will want to get on board with it.
What are the implications of things like containers as far as this is concerned?
So containers don't actually add that much difficulty to it. They don't interfere with that much, because most of the time, most container systems, they'll be sharing the same file system cache. Some containers, like Docker, work best when you have special file systems that do like copy on write and stuff like that. But if anything, that means that the file system cache is even more important, right? Because, you know, files that are shared by all these containers can share file system cache as well. Whereas, you know, typically we think of machines as having their own file system cache. With containers, that line is kind of blurred even further. It might, like right now, it would work just fine with containers if the containers are running SSH inside them, and you can just SSH them like any other remote. But a lot of people don't treat containers that way. So in other words, to properly support containers, I might need to have a kind of a container level visibility features, so that I can actually say, you know, this cache is part of this container, and this line is part of this container. as opposed to just the host machine. But yeah, I very much want to support containers. And it's not that much of a stretch at this point for me to do that. All right, well, thank you all for listening there. And that's
Thank you very much. Let's see, I'm hoping this didn't blow up on you.
Do you have any ideas on how you
another is that I want to have it so that it gathers